है सुधीर सर को फोन करके बोलो फिर एक जना सर बोलो एक बार फोन करके उनको
Hello. हाँ
सर आई नहीं है अभी सर ये क्या आ गया नहीं पता नहीं ये ओपन है ना ये क्या ओपन हो रहा है कहाँ से आया प्रवीण सर आ गए
Good morning to all.
Good morning, sir. Good morning.
Good morning.
Dr. Tripti, you can start.
Good morning, sir.
yes
You
sir
can start.
Good morning,
sir.
sir.
yes sir
Good morning.
आप आएगा तुम कितनी आएगी है
Dr. Tripti, you can start.
yes sir I'm starting just for 1 minute sir ठीक है वर्ड तो नहीं दिख रहा मेरा A very good morning to all. Anyone who stopped learning is old, whether at 20 or 80. Anyone who keeps learning stay young. Well said by Henry Ford. I, Dr. Tripti Lamba, Associate Professor from Computer Science Department and convener for the FDP on Emergence of Blockchain Technology and Cryptocurrencies, privileged to welcome all the dignitaries participate for the most awaited session. Session is hosted by IITM, Institute of Information Technology Management, set up in 1999 under the aegis of Mata Leelavati Shikshan Sansthan, a registered education society engaged in philanthropic activities. Affiliated to Guru Gobind Singh Indraprasth University, New Delhi, aggregated voice oh mute on
म्यूट
Oh,
कर रहा है
I'm so sorry. It was mute. Am I audible now, sir? Am I audible
Now
now?
you are audible. Now you are audible.
All right. I'm so sorry. I'm so sorry. All right. I once again start. Good morning to all.
बीच
Anyone
वाली
who's
लाइन में बैठो प्रॉब्लम आ रही है
anyone who
सारा काम
stopped
छोड़ के वहां
learning
बैठो
is old, whether at 20 or
अच्छा
80.
चल
Anyone
सही
who keeps learning stay young. Well said by Henry Ford. I, Dr. Tripti Lamba, Associate Professor from Computer Science Department and convener for the FDP on Emergence of Blockchain Technology and Cryptocurrencies, privileged to welcome all the dignitaries and participants for the most awaited session. A session is hosted by IITM, Institute of Information Technology Management, set up in 1999 under the aegis of Mata Leelavati Shikshan Sansthan, a registered education society engaged in philanthropic activities. Affiliated to Guru Gobind Singh Indraprasth University, New Delhi, accredited grade A by National Assessment and Aggregation Council, approved by AICT, rated at category A by SFRC and A by JEC Government of NCT of Delhi. It gives me even pleasure to welcome all the resource person. I'm extremely thankful to Professor Dr. Sudhir Kumar Sharma, Director, IITM, and management of the Institute for providing me an opportunity for organizing 1 week faculty development program for the faculty members, academicians, research scholars, and industry professionals. Now, I would like to request the pillar of our institute, Honorable Director, Professor Dr. Sudhir Kumar Sharma, for the inaugural. Over to you, sir.
Thank you, Dr. Tripti. Good morning, everyone. It is often said that great things happen when great minds gather together. I, Professor Sudhir Kumar Sharma, Director IITM Janakpuri, welcomes you all in the 1 week faculty development program on emergence of blockchain technologies and cryptocurrencies. I extend a warm welcome to Professor Parveen Chandra, Dean, University School of Information and Communication Technology, Guru Gobind Singh University, Delhi, as a chief guest. I extend a very warm welcome to Dr. Bharat Bhushan from the Sarda University as a resource person for the first session. The main objective of the FDP is to provide the core knowledge in the domain of blockchain and its applications to the academicians, research scholars, and industry professionals. The FDP comprises of intuitive lectures, hands-on experience, along with distributed platforms like Ethereum. Now over to Dr. Tripti.
Thank you, sir, for your kind words. I profusely delighted
Tripti,
to
unmute yourself.
All right. Thank you, sir, for your kind words. I am profusely delighted to take an opportunity to introduce our chief guest of the day, Professor Dr. Praveen Chandra, Dean at USICT, University School of Information, Communication and Technology, for his kind acceptance to grace the event. Sir, you hardly need any introduction. We have made all of us, you have made all of us proud of your distinguished work in numerous capacities. We are truly blessed with your presence. Sir has received PhD in IT from Guru Gobind Singh Indraprasth University, Delhi in 2004, MTech degree in Computer Application 1998 from Indian School of Mines, Dhanbad, Jharkhand, and MSc degree in Physics from University of Delhi in 1993. Since 1999, he has been with USICT, Guru Gobind Singh Indraprasth University. Currently, Sir is the Dean at University School of ICT, Guru Gobind Singh Indraprasth University. Currently, Sir is interested in mathematical properties of neural network and the related of these properties to observe physical properties. Her teaching and research interests are in the areas of artificial neural network, algorithm design and analysis, DBMS, theoretical computer science, complexity, multiple criteria, decision making, programming languages. His doctoral research work in the area of sigmoidal functions in a feed-forward artificial neural network. Sir, I once again welcome you for the inaugural speech. Over to you, sir.
Good morning to all.
Good
First,
morning,
thank
sir.
you. You got almost everything right other than my MTech
Okay.
period. I did my MTech in 96, not 98.
All right. So sorry,
Okay,
sir. Okay.
that's okay. Must have taken all this information from the net. There can be a
Yes.
mistake.
All right.
Anyway, now this FDP, if I understand correctly, is blockchains and blockchain application in cryptocurrency. Now, this has come into, I call it a fashion in the last 5 to 10 years. But we must understand that as a digital currency, the first David Shom gave it in 1980, early 80s. Then he implemented it as a in 19 mid 95, around 95, mid 90s. But it is also true that the first Bitcoin application of a distributed ledger, which is a blockchain, came in 2009, 2008 when Satoshi, and God knows who is this person Satoshi, everybody is looking for him, implemented the Bitcoin paradigm. Now, if you look at this blockchain actually implements something which is known as distributed ledger for security, which means it's actually nothing more than a distributed database of information. Please understand, when I use the term database, it is not a RDBMS. It only means that it is a set of records which is distributed at multiple places. And it implements security in a very simple fashion. If I want to manipulate a record at X position, if wherever this X is referenced, it must be manipulated. And which is a simple thing. If the majority of the system wants to manipulate, they can manipulate. Otherwise, the data cannot be changed. So it appears to be a sort of a democratic but secure system. Now, I will not get into the details because I looked at the brochure. It says 10:30 to 10:45 is the inauguration time. And we have started 2 minutes late and we have got only 2 minutes. Some of the speakers are people who are interested in this area. I know almost half of them. Not everybody, but I do know half of them. They might be speaking in detail about how it happened. My only advice to all the participants is don't get blown away by the fashionable terminology and things. Understand it. It implements a structure which was given in 1980s. It's not a current thing. And you can talk in terms of multiple applications. Cryptocurrency is one application of blockchain, not the only one. The moment you have to provide security in a distributed system, blockchain effectively is a solution to the problem of distributed systems security problem. So think in general. Don't think only in terms of this. It can be used for, and it has been demonstrated as two-party contract, multi-party contract. In fact, in-party contract also can be implemented using this. So it's a generic system which can be used for securing data on a distributed system. In general, in specific, it is being used for giving you bitcoins and cryptocurrencies only. With this, I hope all of you will learn a lot. 6 days is not less. 6 days is a lot if you remember your basics. So hope for that you remember your basic and can learn the advanced things. Thank you all.
Thank you, sir, for your very thought-provoking and interesting address to the educators. We really appreciate you taking out time for us from your busy schedule and sharing your valuable insights. Now, I would like to extend our warm welcome to our first speaker of the morning, Dr. Bharat Bhushan. Dr. Bharat Bhushan is an assistant professor of Department of Computer Science and Engineering at School of Engineering and Technology, Sharda University, Greater Noida. He received his undergraduate degree with distinction in 2012, received his postgraduate MTech in Information Security with distinction in 2015 and doctorate degree in 2021 from Birla Institute of Technology, Mesra, India. He earned numerous international certifications such as CCNA, MCTS, MCITP, RHCE, and CCNP. He has published more than 80 research papers in various renowned international conferences and SCI Index journals, including Journal of Network and Computer Application, Springer, Sustainable Citizen Society Elsewhere, and Emerging Transaction on Telecommunications Village. He has contributed with more than 25 book chapters in various books and has edited 11 books from most famed publishers like Elsewhere, IGI Global, and CRC Press. He served as a keynote speaker numerous reputed international conferences held in different countries including India, Morocco, China, Belgium, Bangladesh. He has served as a reviewer, editorial board for several reputed international journals. In the past, he worked as an assistant professor at HMR Institute of Technology and Management, New Delhi, and network engineer in HCL Infosystem Limited, Noida. He has qualified GATE exam for successive years and get the highest percentile of 98.48 in GATE 2013. He also a member of numerous renowned bodies including IEEE, IENG, CSTA, SCI, EI, IAE, and UACEE. Now, I would like to request Dr. Bharat Bhushan to talk about securing system using blockchain technology. Over to you, sir.
Good morning, one and all, and thank you for this warm welcome. I hope I am audible and the screen is visible.
Yes, sir, you are audible and the screen is also visible, sir.
Okay, so thank you everyone and for this welcome. And we'll take on respected Dr. Praveen sir said blockchain is a fashion word. So I'll just try to, explore this fashion word a little bit. So starting on the topics that we'll be seeing today, I'll be simply putting forward a formal definition of blockchain technology and how is this different from the traditional database that we have been using till now. And we'll see how a transaction is actually realized in blockchain technology. And we'll take the example of a Bitcoin, of course, because it is, the most discussed word nowadays. And then we'll see the architecture of blockchain and classification. Further, if time permits, we'll also be seeing several problems in Internet of Things realm and how this blockchain can be used to, counter those issues. So we have a term that is BIoT, blockchain-based Internet of Things. And then we'll see certain application areas and finally look forward to, need of blockchain in today's world. So first thing is blockchain. We might have heard something about linked list, isn't it? We have a data structure, linked list as a data structure, where different nodes are linked to each other on the basis of memory addresses. So the nodes are linked to each other based on memory addresses. Based on this concept only, the blockchain is also devised. Here, instead of nodes, we have several blocks and these blocks are linked together, connected to each other by some kind of a link. Here I am not discussing what that link will be at this point of time, but yeah, it is similar to linked list where the blocks are connected to each other by some kind of a link. So we call this a distributed data structure. And this is a formal definition, not a formal definition, but I had tried to incorporate all the different concepts in one single line. Like, let's read it first, that blockchain is a decentralized computation and information sharing platform. So what this blockchain is, it is nothing but a platform. It's a technique that allows you to share information in a decentralized manner. Okay, and who will be sharing this information? Multiple authoritative domains. That means multiple peers will be sharing their information on this platform. And the important thing is that these peers, these domains do not trust each other. Maybe for cooperation, coordination, or collaboration, they don't trust each other, but still they want to reach to a rational decision-making process, or they want to make some correct decisions. So this is a line, that has summarized several points. So we'll be discussing all these points before we come to the formal definition of a blockchain technology. So the first word is a decentralized computation. Decentralized, we all have heard about this word, centralized architecture, isn't it? Where we generally have a central coordination system and several peers, several nodes are actually connected to this central coordination system. And it is this central server that gives orders to all the connected peers. So there is a very big problem associated with this centralized architecture. The fact that if this centralized architecture, if the central server or the central system fails, all the node is going to lose its connection and the system will crash. So in order to avoid this, in order to overcome this particular disadvantage, we have the concept of a decentralized architecture where, instead of putting all the burden on one central coordination system, we have several coordinator nodes. And these coordinator nodes are also connected to each other. It is a point to be noted that there are some designated nodes that serve as a coordinator nodes. And normal nodes or the individual nodes, they connect to these coordinator nodes to receive the order. So the problem here, the problem of the centralized architecture is solved in this case, because if suppose some of the coordinator nodes fail, the individual nodes can join some other coordinator node, and there are some algorithms which coordinator node it should join and all. So that will be discussed in the later half of this program. Here in the decentralized architecture, if some coordinator nodes fail, we have an option to join some other coordinators. So it is resistant to few failures. Decentralized architecture can work even under few failures. But the blockchain, we say it is a decentralized architecture, but you cannot really say it is a decentralized architecture. There are three architectures: centralized, decentralized, and we have a distributed type of a network. Distributed network is something that is the enhanced version of a decentralized architecture. Centralized system, you can see all the nodes are connected to a single authority. In the decentralized network, we have several coordinator nodes. These are the 6 coordinator nodes you can see. And the important nodes are joining these coordinator nodes for receiving orders. But blockchain does not directly use the concept of decentralized architecture. Here, it is an enhanced version of decentralized architecture. We call it distributed network, where the nodes join to the coordinator nodes, and all these nodes are also connected to each other. So blockchain is something that uses a decentralized, distributed network, enhanced version of decentralized computation. And it is an information sharing platform. Second term that we need to know is the information sharing platform. So initially, the traditional way of information sharing is if we are working on some work. For example, here Bharat and Bharati, if suppose they are working on a project. So what Bharat will do, he will write his content in the MS Word file, for example, and he will send it to Bharati. and then Bharti can rectify or edit or perform her part, and she will again send it back to Bharat. But the problem is, when Bharti is working, Bharat cannot work, and when Bharat is working, Bharti cannot work in this traditional way of data sharing. So both Bharat and Bharti is not able to simultaneously edit the document. So this is a problem in the traditional way. Then we have the concept of a shared Google Doc. In this, we have a central server where we put a particular document, and both Bharat and Bharti can, edit the document simultaneously. The concept of centralized environment still is there, and yeah, the centralized system does harm you. How if suppose the central server, this shared Google Doc is lost, the entire thing will be lost, the content will be lost. Bharat and Bharti does not have their own copy with them. If this central server is crashed, the document will be lost. So in order to overcome this problem, we have an ideal solution, that is the blockchain way. So the blockchain uses this concept. We cannot say this is the blockchain. It uses this concept where the Bharat has his own copy, Bharti has her own copy. Both the users are having their own copy, and they can independently write their personal copy. But we have the internet to maintain the consistency. If Bharat is editing something, that will be reflected into the Bharti's document, and when Bharti is editing something, that will be reflected in Bharat's document. So blockchain concept actually ensures that whatever is written by both of these users is getting synchronized with each other, and both will be able to see the most updated copy of the document. So in this solution, in the blockchain way, both the users can simultaneously read and write a particular document. So this is information sharing platform, and this is how blockchain is actually realized as an information sharing platform. And next concept we had seen is a multiple authoritative domains. So here we can see, suppose there are 6 or 7 nodes. What happens is every node will maintain a local copy of the global data sheet. Means there are every node, every peer is having their own personal copy, and whatever, suppose node 2 is performing some transaction, or if he is performing some action, it will be automatically reflected in the local copy of all the other nodes. And whatever transaction is being performed, so it is actually, please mute, some voice is coming, please mute. So whatever transaction is being performed, all the historical information is also available in the global data sheet, and we call this global data set to be the public ledger. Means whatever transaction is being performed by all these 6 nodes, this is reflected in the public ledger, in the data sheet, global data sheet, and we call it a public ledger. And in order to ensure consistency, there are 2 rules that this blockchain actually follows. First one is that local copies at every node is identical. Means whatever transaction has been performed, it should be reflected in the local copy of each and every node. And also these local copies are updated on the basis of the global information. Now the thing is how this local copy is updated, how the information is added to the public ledger. This is a matter of concern. We'll be seeing this later. And then rational decision making. So what do we mean by rational decision making? That is another term that we have used in that slide. So suppose there are 4 persons, Bharat, Bharti, Vector, and Eve, and we had seen that every user in the blockchain network have a local copy of the public ledger. So initially it is known that Bharat is having $100 within his account. Can you please mute? There is some unwanted voice coming on. Am I audible?
Yes, sir, you are audible, sir.
Bhavika Charu saying,
Please
kindly off your mic, unmute your mic. Dr. A. Rajendran, Bhavik. Oh, okay, Dr. Bharat, you can start.
Yeah. So in the rational decision making process, we had known that every user in a blockchain network, they have their own local copy. Suppose if Bharat is having $100 with him and it is known to all the peers. Now, Bharat wants to send rupees 50 to suppose Bharti. Now, what is this 50? How is it being sent? It is being sent in the form of a transaction. Bharat does a transaction of $50 to Bharti, and that transaction is reflected in the public ledger of all the four users. If Bharat had sent 50 to Bharti, that is reflected in the public ledger or the local copy of all the users. Now, there is a lot of story behind if this transaction is valid, who will validate this transaction, but at this time we are only understanding the definition. So if now in this case Bharat has sent $50 to Bharti and it is reflected in the public ledger of everyone, and then Bharti wants to send rupees 30 to Eve. Now the thing is Bharti is having rupees 50 and
Not audible.
सर म्यूट हो गया सर, आपने सबको म्यूट कर दिया है.
Sir, you are on mute. You are not audible.
सर मेरा म्यूट हो गया है, क्या बोलूं?
am I audible?
Yes, sir, now you are audible, sir.
Now you are audible.
So suppose Bharat wants to send $50 to Bharti, so he will send this in the form of a transaction, and this transaction will be reflected in the public ledger of all the peers, all the other participants in the network. So, and then in the second case, Bharti wants to send $30 to Eve. Now, what will happen if Bharti wants to send $30 to Eve? She will first generate a token. Whether this she will first generate a token, whether she is allowed to send rupees 30 to Eve, and everyone in the network will validate. Everyone in the network have the opportunity to validate whether that transaction is valid or not. If it is valid, that transaction is performed, and again that is reflected in the public ledger of all the four users. So the first two transactions were valid and it were reflected in the public ledger of all the four peers. Now the thing is, Bharat have initiated a new request that I will send $80 to Vector. Now, this request will not be granted because this request is not granted because everyone in the network knows that Bharat initially had $50, $100. He has given $50 to Bharti. Now he is left with only $50. How can he make a transaction of $80? So this transaction will be discarded, and a discarded transaction is not updated in the public ledger of the users. So this is how, as everyone is available, has the information about the funds remaining with Bharat, so this new transaction of $80 will be, discarded. So the data in blockchain is replicated all over, and this replication gives us some advantage. See, this data, this public ledger is replicated to with everyone. So if there is a loss of data, so that can also be countered, and also it ensures that data integrity is maintained. So data integrity is maintained because of a hash function, a cryptographic hash function. We'll see the details of data integrity later. So at this point of time, replication allows you to overcome the problems of corrupted data, and also allows you to secure your data, prevent data integrity. And then consistency of the data is maintained by a process called consensus. What does this consensus mean? I said this $80 transaction is not permitted. Why is it not permitted? Because all the other users of the blockchain network, all the peers, did not validate. They did not give their consent. They did not reach to a consensus. So consensus means everybody agrees that the data that goes into the data structure is what they agree to put there. Means whatever is validated by everyone, okay, that data is only going to enter into the public ledger. And for linking between the nodes, as we said initially, nodes, the users are linked. So with some kind of technique, we call that technique as hash linking. We use a cryptographic technique called hashing to link these nodes, to link these blocks in a blockchain network. Further, blockchain helps you to provide provenance, maintain integrity, privacy, authentication, and confidentiality. These are some primary terms of information security, which I am not exploring. So these are the things that blockchain actually provides. It helps to reduce the manual intervention. Transparency means whatever scenario is happening, that is reflected into a central public ledger, and that is updated in the local copy of all the users. So this is transparency. And immutability is whatever is updated in the public ledger, that cannot be, rolled back. The transactions that has actually occurred, those transactions can never be rolled back. So it is impossible to tamper the public ledger. So we also call blockchain to be a tamper-proof architecture. So with this background, we now are ready for a formal definition of a blockchain, that is an open distributed ledger that can record transactions between two parties very efficiently and in a verifiable and permanent manner. Open. Why open? Because all the information is accessible to everyone in the network. Distributed, because there is no single party that is controlling the entire network. Efficient, because it is fast and scalable, we'll see how. And verifiable, because everyone is checking the validity of the information. Further, it is permanent, it is tamper-proof, because the information entered in the blockchain cannot be updated in future. Whatever is inserted, whatever information is listed in the public ledger cannot be changed. The transactions that are committed can never be rolled back. So this is a formal definition of blockchain. And how does this differ from a centralized architecture, traditional centralized architecture? In a traditional architecture, suppose a user wants to access some data, suppose X, what will he do? He will send a request to the centralized server, to the trusted third party, and the trusted third party, based on the authentication or authorization mechanism, whatever it is using, based on this, it will send a response. In case of blockchain, if you want to access a data, in figure B you can see the user wants to access the data X. Now it is the responsibility of all the users in the blockchain network to reach to a consensus, to reach to a decision, and user will receive a consensus response in the blockchain network. So this is a basic difference between traditional database and the blockchain scenario. We have a centralized storage, a decentralized storage. We need a database administrator in the traditional database, but there is no need for an administrator in blockchain. Further, modifying data requires permission from the database admin, where there is no permission requirement for modifying data in a blockchain. Every user has their copy. They can modify their copy, and their copy is not going to affect the master copy until and unless that transaction is validated by everyone. So blockchain, we can say, is irresistible to the data modification, and information is up to date in a traditional database. For example, suppose you have 10,000 rupees, Bharat is having 10,000 rupees in his account. So that is up to date in a traditional database, but performance. What were the transactions that have been performed, and currently he is standing at this point, so everything will be there in the public ledger. And the centralized database are used as databases, but blockchain, if you use it a database, the performance will be slow. We can use as a platform for some transactions. So once we are now aware of the definition of a blockchain, moving on to how a transaction is actually realized. In the slide, I had said that Bharat said that he wants to do a transaction of ₹80 that was denied. And Bharti said she wants to do a transaction of $30 that was accepted. How this is denied, how this is accepted, we'll be seeing in this particular slide. For example, suppose we take the common name Elise and Bob we find everywhere. So Elise wants to send some amount to Bob. Now, the first block, Elise will open her Bitcoin. This is transaction life cycle we are studying in terms of Bitcoin wallet. So Elise, if she wants to send some amount to Bob, she will first open her Bitcoin wallet, and after opening the wallet, two things needs to be defined. To whom you are giving address of the recipient. So Alice will provide the address of Bob and the amount she wants to transfer. Now, Alice will give the address and the amount and click on the send button. Once the send button is clicked, the request is made. Okay, once the send button is clicked, the wallet will construct a transaction and it will digitally sign it. I am not going into detail of the digital sign at this point. We'll see it later. So the transaction is constructed and is digitally signed and broadcasted to the network. So this transaction is broadcasted to the network. Now all the peers, all the network nodes, what these nodes will do, once they receive a transaction, they will validate the transaction, whether the transaction is valid or not. Now, in the case where Bharat was sending $80, that transaction was not valid. So that step will be aborted in the fourth block. So the network nodes validate the transaction based on the existing blockchain, and if it is validated, it propagates, these nodes propagate the transaction to someone called miner. So we have some special nodes in the network. They are designated miners. They perform some other responsibility, like what the miner will do. They have received a transaction. If Alice wants to send some amount to Bob, now they might have received some other transactions as well. So it is the responsibility of the miner to include these transactions into the block. What is a block? Block is nothing but, at this point of time, I am saying that block is nothing but several such transactions form a block. So miners will include this validated transaction to the next block to be mined, and they collect all the transactions. All the valid transactions are collected and we construct a new block. Now, this new block needs to be added into the blockchain network, into the existing series of blocks. So there should be some mechanism by which we are going to add this newly created block that consists of validated transactions. How we are going to add this new block to the existing blockchain? So this is realized with the help of a cryptographic technique that is called cryptographic hash function. So once the transaction is validated, it is aggregated in the form of a block, and the block is then added to the existing blockchain using the cryptographic hash technique. And once the mining is over, the block is included in the existing blockchain. Then what happens? The updated ledger, the public ledger, gets updated after this block is added, and this updated ledger is propagated throughout the network. Now every node will receive key, this particular block has been mined, added to the new blockchain, and this is the new public ledger, and it will be reflected in the local copy of all the users. So in the last step, we can see once the Bob opens his Bitcoin wallet and he refreshes it, the blockchain will get updated and the transaction will be reflected at the Bob's wallet. So this is how a transaction is being reflected, is being realized in a Bitcoin network that uses the concept of blockchain technology. So we'll be seeing it pictorially in this. Suppose the transaction is initiated here, a transaction is requested here, and this request is then sent to all the peers. So every peer, these are the 4 peers in the peer-to-peer network, in this particular network, and these will first validate the transactions. Only if all the peers in the network validate a given transaction, this transaction will be, aggregated in the form of a block. This transaction can involve anything like cryptocurrency, contracts, records, or any other information can be aggregated, and a block is formed. Now, this verified transactions are combined with other transactions to form the block. Now, this is the block that is formed, and this block needs to be added to the existing blockchain. That is existing series of blocks. So newly created block is added to the existing chain of blocks, and this adding is done with the help of cryptographic hash. And once it is added, the transaction is completed, reflected in the public ledger, and updated in the local copy of all the peers. So the same thing in the steps involved in Bitcoin transaction is nothing but initiated transaction is initiated, broadcasted to the network, and then miners verify the transaction, bundle them into blocks, and they race to solve a cryptographic puzzle. Now, performing this addition which block, so that is decided by solving a cryptographic puzzle, and miners spend some energy on in solving this cryptographic puzzle. They also gain some reward in the process. So these things will be discussed in the later half. So the winner of this cryptographic puzzle will be adding this block to the blockchain, and this cannot be altered. So every node will receive a copy of the updated chain, and this is how a transaction is realized in a Bitcoin scenario. Talking of the blockchain architecture, we have several blocks, as we said, and these blocks are linked with the hash. Now the important thing is the block n will be linked with the hash of block n minus 1. Block n plus 1 will be linked with block hash of block n. Means every block is linked with the block hash of the previous block, and here you can see these are having several transactions. Every block will consist of several transactions, and these are linked to each other with the help of a hash function. So these blocks are identified by the cryptographic hash, and these are linked with the hash function. And these, apart from the transactions and the hash, there are several other things as well. Before that, we'll see the first block, we call it a genesis block, and these are some next blocks. You will see that hash of the first block is a random hash, and then in the second block, hash of the previous hash of the first block is a random one, and hash of this block is similar to the hash of the second block. Hash of the second block is similar to hash of the third block. So if the adversary wants to change the data, if the attacker wants to tamper some of the blocks, he will have to tamper each and every block within the blockchain, and it is merely impossible because complexity here is increased to such an extent that till you will be tampering, you will be able to tamper all the blocks, some new block will get added. So adversary or the attacker never reaches the last block. So this is why the security in a blockchain technology is paramount. So apart from the transactions, we have several other things in a blockchain block structure. Two basic components. First is the header, second is the body. In the header, we have the metadata like nonce, n bits, timestamp, Merkle tree, root hash, the parent block hash, and the block version. So these are the things in the block header, and the block body consists of the validated transactions. You can see transaction 1, 2, 3, 4, n. So these transactions, once were validated by the peers, were aggregated in the form of a block, and it was added to the existing blockchain. And every block is linked with the help of the hash of the previous block. Transaction is nothing but a data structure that relates to the transfer of assets among peers. What asset is being transferred between the peers in a blockchain network, that is reflected in the transaction. So there are several core components of a blockchain system, like we have asymmetric key cryptography, the blockchain itself, that is the secure distributed ledger technology. We have several consensus algorithms, and how a transaction is actually formed. So we'll be seeing these in detail one by one. Before that, there is a hype around cryptography and blockchain. So how is this blockchain, taking help of these cryptographic schemes? So it uses cryptography at 3 stages. First one is for initiation and broadcasting of transactions. The blockchain makes use of digital signatures and public and private key. Then second phase, after the transaction is initiated and broadcasted to the entire network, we need to validate that transaction. And in order to validate the transaction, blockchain uses the concept of consensus mechanisms. There are several consensus algorithms like proof of work, proof of stake, delegated proof of stake, PBFT, practical Byzantine fault tolerance. So there are several consensus algorithms that is used to validate the transaction. And then for the chaining of blocks, we use the cryptographic hash function. So starting with the hash function, hash is nothing but a function that maps any size data to a fixed size. For example, if you have any size data, maybe 1000 bits or whatever you have, it will be scaled down to some range. For example, just take that hx is equal to x modulo n. So this hash of x is calculated as x modulo n. So modulo function is not at all a hash function. I'll prove it, but you can take for this to understand this point, we can use this concept of modulo. Okay, so x can be of any length, but whenever you apply modulo n to this x, that length will be scaled between either 0 to n minus 1. So for any two different values of x1 and x2, hx1 and hx2 should be different. If you take this example, this point will not be valid, but for other things it will be valid. So I had taken this example of modulo. And the biggest advantage for this is it is a one-way function. For example, suppose you have two numbers, suppose 34 and 47. So 34 and 47, if you have apply modulo 5, so you will have some number. So for two numbers, the hash of the two numbers should be different. And if you are, suppose 34 modulo 5 is also 4 and 39 modulo 5 is also 4. So if you get the hash function, if you get the output, you will not be able to get the input. From 4, you cannot guess whether it is 34, whether it is 39 or it is 44. So it is a one-way function. Hash function is a one-way function. Means from input you can go towards the output, but from the output you cannot come towards the input. And this actually causes an avalanche effect. Now what is this avalanche effect? In cryptography we use this term avalanche effect. It is like even if you make a slightest change in the input, you will see a significant change in the output. So this is the avalanche effect. So hash function has the avalanche effect. It follows one-way function. There are three properties of hash function we'll be seeing later. So here, how this is realized, 4 things: sequence number of the access, client ID, timestamp, and the hash value of the previous block. So these are the 4 functions, 4 things that on which we apply the hashing algorithm and we generate the hash of this. So hash of block 1 is generated with the help of by applying hash function over these 4 attributes. And out of these attributes, you can see it also takes hash of the previous block H0 as one of the attribute. In H2, it applies hash function on 4 attributes. Out of this, H1 is something that is related to some other block. So if you tend to change somewhere here, tamper the data somewhere here, it will be reflected in H2, it will be reflected in H1 and all the preceding blocks. So tampering a data in a blockchain network is merely an impossibility. So there are several properties of a hash function. First is collision free. Collision free means if you have 2 messages and the 2 messages are different, like M1 is not equal to M2, then the hash of the 2 messages will also not be equal. If the 2 message is unequal, the hash of the 2 message is also unequal. So whatever hash function you are using, that must satisfy the collision free property. Also, it should be a one-way function, means from a given input you can get the output, but from a given output you cannot guess the input. And further, it should be puzzle friendly, means suppose you have an input x and k, so you apply a hash function on this x and k and you get something called y. So if you are given y and x, you cannot compute x. Okay, so computing k is difficult from a given x and y. So this is puzzle friendly. This is
I request participant to mute themselves, please. Kira madam, can you please mute? Thank you. Yes.
So am I audible?
Yes, sir, you are.
So these are the 3 properties that a given hash function should actually, satisfy. That is collision free, hiding, that is one-way function, and the puzzle friendly. Then we have the concept of digital signature that we use in blockchain technology. Why is this digital signature used? Because to verify the content, to verify the identity, and also to prevent non-repudiation. Means to verify the content means whatever data you are sending, that data is not modified. Verify the identity means whatever data you are receiving, that is from a valid sender or authorized sender. And non-repudiation means if somebody has performed a transaction, he cannot refute the claim of sending that data or performing that particular transactions. And we follow 2 different rules, 2 basic rules in our digital signature, that only the signing authority will be signing a document and all others will be verifying the signature. So everyone in the network can verify the signature and the signing authority will sign it. That is rule number 1. And the rule number 2 is we cannot transfer the signature. So signatures for a particular document is non-transferable. We cannot transfer the signature. So based on these 2 rules and based on these 3 objectives, we have the concept of digital signature. So here we are simply seeing the concept of encryption and decryption, where a message M, after performing encryption with the help of some key, we get M dash. Kindly mute and then
Sir Rupa sir, can you please mute yourself?
So next is in the decryption, we have the same message can be decrypted with the help of a key and we can get the original message. So if you use the same key for both encryption and so if you use the same key for both encryption and decryption, we call that a symmetric key cryptography. And if we use different keys, we say it is a asymmetric key cryptography. Now, in asymmetric key, with the blockchain scenario actually uses asymmetric key cryptography. So we have 2 different keys, a public key and a private key. Now, as the name suggests, public key of all the users, all the peers is known to everyone. So everyone knows the public key, but the private key is personal. For example, if we have 5 users, the public key of all the 5 users will be known to everyone, but they will know their private key personally. So we use the public key to encrypt a message. So if suppose Bharat wants to send a message to Bharti, what will he do? He will encrypt the data using the public key. And Bharti can, the thing is, it operates like if it is encrypted by the public key of one user, it will be decrypted by the private key of that particular user. So if Bharat knows the public key of Bharti, he can encrypt the message with the public key of Bharti, and this message can be decrypted only with the private key of Bharti. Now, who knows the private key of Bharti? Nobody except Bharti. So it is only Bharti who will be able to decrypt this message using her own private key. So nobody else has the access to this particular message that is sent intended to Bharti. So this is how security the content of the data is not changed, so is not revealed. So this is only one objective that is achieved. In order to achieve the second objective, we need some more modifications. So we have RSA algorithm, Reverse Samir Adleman algorithm that basically these technology use, in which the plain text is converted to ciphertext with the help of a public key. If you want to send the message to some people, you can take his or her public key that is known to all and encrypt the message, and that message will be decrypted using only that particular person's private key. So it is only he who will be able to decrypt the message and gain access to the information within the message. So I'm not, because of time constraint, I'm not going into the details of this RSA algorithm. Only the thing is, we use 2 different keys in this, that is EN is a public key and DN is the private key that we use. And M is the message to be encrypted. How this thing is realized? We choose 2 prime integers, a P and Q. This is the standard algorithm, the RSA algorithm. So we first take 2 prime integers, distinct prime integers P and Q. We compute the value of N. This N is nothing but the key length. And then we compute the Authoritative function representing by phi n using equation 5. And then we choose an integer E, such that E and phi n are co-prime. Co-prime means the GCD of E and phi n, the greatest common divisor of E and phi n is equal to 1. And then we determine D, that is the modular multiplicative inverse of E mod phi n. And it is a noticeable point that D into E is 1 mod phi n, that is, these are co-prime. And once we have the value of D, E, and N, we can form a public key as EN. So the public key will be EN and the private key is DN. So we use EN for encryption, we use DN for decryption. The public key EN is sent to all, sent to the network, so it is available with everyone, and the private key DN is kept private with the given user. So what happens, the Bharat will be, instead of sending only a message, he signs the message with his private key. So what happens, he has encrypted the message and he is signing the message with his private key. So if Bharat is signing the message with his private key, Bharti will be able to decrypt that with the help of his public key. So if a message is being decrypted with the public key of Bharat, it automatically means that it is only Bharat who has sent the message. So the message content not being altered is a different thing. This is verification of identity. So in order to verify the identity, if Bharat encrypts a message with his private key and it is decrypted by Bharti using the public key of Bharat, we say that Bharat cannot refute the claim of performing a particular transaction. So in order to reduce this signature size, we use the concept of message digest to sign. So instead of original message, we send the message digest. So what will Bharat do? He will generate a hash of a message denoted by HM, and he will sign this message using his private key. Now, if he is signing it with the private key, it will be decrypted by his public key, and he will send this signature along with the message. Now, Bharti, upon receiving the signature and the message, first verifies the signature using Bharat's public key. So she will try to decrypt the signature and check whether this signature is being decrypted by the public key of Bharat. Yes, it is decrypted by the public key of Bharat. So the origin of the sender is verified. If it is being decrypted by the public key of Bharat, we say the origin is verified, and then Bharti will compute the hash of the message. Now, hash of the received message, and one hash she has decrypted from the signature, one hash she has computed. So she can check whether the two hash is same or not. If the hash that she has received after decrypting the message, decrypting the signature, and hash that she has received after computing the hash value of the message, if the two hash is not same, we say the content is altered. So, and if it is same, we say the content is verified. So in this way, both the origin and the content gets verified. So this is how blockchain realizes this concept of digital signature and cryptography. Moving on to the classification of blockchain, we have two different types based on the permission. So there are several bases on which you can classify blockchain technology. First is based on the permission. You can classify it as either permissionless or permissioned blockchain. So as the name suggests, the permissionless blockchain, it is nothing but any node can join or quit the network until unless that particular node has a valid pseudonym, or if it possesses an account address, he will be able to join the network, he will be able to quit the network on his will. There is no authorization requirement in a permissionless blockchain. And nodes can use the common rules to receive, send, and validate blocks. There is no need of an authorization. And the most common example of a permissionless blockchain is the Bitcoin scenario. Whereas in case of permissioned blockchain, before you participate in the network, you need to have go through a proper authorization. So permissioned blockchain requires proper authorization of the participants, and every participant need to reveal their identity. It is effective network governance, and every participant will be revealing their identity in this permissioned blockchain. And this permission blockchain scenario is more useful in internal business applications and multi-party applications, where you don't want somebody from outside to join your network. And then on the basis of participation also, you can classify blockchain as public, consortium, and private blockchain, where in the public blockchain, we have some specialized nodes, and that is called the minor nodes. So it is the responsibility of the minor nodes to form a block, to mine a block, add a block to the existing blockchain in the public blockchain. And the most common example of a public blockchain is Bitcoin or Ethereum. And then second is the consortium blockchain, where we have some predefined set of nodes that controls the consensus process. So we can say the consortium blockchain operates under a group leadership category. So it is partly private, partly public. We have some predefined nodes that perform the consensus mechanism, and Hyperledger is an example for a consortium blockchain. And then we have the private blockchain category, where anybody can read, but writing permissions is given only to a decentralized authority. So one entity in a private blockchain rules the entire system in case of private blockchain. So these are the three generations of blockchain. You can say first generation, as we all know, it is a Bitcoin technology generations. Bitcoin was proposed by Satoshi Nakamoto in 2008, and this first generation of blockchain technology, it was limited to money transactions only. And then we moved on from money transactions towards some assets, towards some shares. So in the second generation of the blockchain technology actually focused on the assets, the shares, where the user can exchange numerous assets, including the properties, boats, goods. Nowadays, we can see blockchain have been used extensively in several application areas like in goods traceability, in supply chain management, in preserving the electronic healthcare records in a healthcare scenarios, in electronic voting. So there are a number of things where this blockchain is actually managing the assets or the shares. That is the second generation, and nowadays we have the third generation, that is smart contracts, where different users can enter into a contract. They put the given contract in the blockchain technology, and we cannot modify the particular contract. So smart contract is the third generation of blockchain technology. And this contract is a programmable contract that can be checked or verified by all the participants. And this enables the various peers in the blockchain network to follow the contracts very strictly. And you cannot, of course, tamper the contract or modify the content that is already put in the public ledger. So smart contracts also use the concept of blockchain technology. And there is, numerous growth of blockchain. There are numerous occasions where we can say the blockchain has tremendously grown. So Ethereum grew 50 times from its inception, and then ICO also investments also increased 16 times. There is a lot more number of jobs being posted related to blockchain scenario. The global blockchain market is, expected to reach 20 billion USD in 2024. So it is a big number. And then banks are also experimenting, and now most of the banks have actually implemented this thing in blockchain technology in their
your message has been given to
applications. And then bankers also expect the commercial blockchain adoption by next year. 33% of bankers are expecting this. So there is enormous growth in this blockchain scenario. I tried to define the blockchain and lay down the foundation of cryptography, how the cryptography actually supports blockchain technology, what are the concept of hash. These things I hope the definition of the blockchain is clear, and the following sessions in this FDP will help you to understand the various application areas and related aspects of blockchain technology. So these are some of the works that I have published in this regard. One is like blockchain for smart cities, and the other one was blockchain for Internet of Things. And the third article that I'm referring will give you the complete understanding of blockchain technology. So these are 3 survey articles related to blockchain that I had published. You can just go through this. It will be helpful. My research interests include wireless sensor network, security in communication, IoT, blockchain, and cryptocurrencies. Thank you, everyone, and open to questions from your end.
Yes, sir. Thank you so much, Bharat, sir. Yes, few questions are there. Like we are connected live to the YouTube also. So there was some question that was been given in the YouTube. I'm just sharing with you, sir, by Dr. Shubham Agarwal. He was asking, sir, blockchain is a kind of a public key cryptography or a private key cryptography?
Blockchain uses the concept of digital signature actually, which is based on both public key and private key. It is using the concept of asymmetric key cryptography. We cannot say that blockchain is based on public key or private key. It will not be fundamentally correct actually to say this. It uses concept of asymmetric key cryptography.
All right. Thank you, sir. Sir, one more question was there from Dr. Shubham only. Can we use Fibonacci primes in a blockchain cryptography?
Fibonacci prime at what place does he want to use that actually?
He has
So,
just written in a blockchain cryptography. Yeah.
okay.
Yeah.
So actually, you need to explore the concepts in a better manner. Okay, you can use this in terms of consensus mechanism. That is one place where you can use this thing. And blockchain is a concept. We cannot directly use this Fibonacci thing here. We can use it and modify the existing consensus algorithm. There are n number of consensus algorithms like proof of work, proof of stake, and several. You can propose your own consensus algorithm as well using this.
All right. One more question was there from Shubhro Sen Gupta, sir. He was asking, sir, throw some light on finding a prime number of 7-digit.
So actually, because of a time constraint, I couldn't. Yeah.
Yes, sir.
So,
Many more questions were there, but we are running short of time.
yeah.
Yeah.
I just tried to wind up the this
Right, sir.
discussion
Right.
in
And the
1 hour
second
exact.
speaker is also waiting.
Yeah,
Yeah.
yeah. So
Now,
hopefully this question will be answered in later lectures also. This is only a blockchain definition.
right.
So
Sir,
yeah,
may I
definitely
ask
we can
one question?
generate. Please,
Hello. May I ask one question?
please.
Yeah, this is Gajanan Gambhire from Vishwakarma Institute of Technology, Pune. Sir, you have told that there are applications of blockchain in generation 1, generation 2. So in second generation, you told that blockchain can be used with assets.
Yes.
So I have understood how it can be used in transactions, but if you consider in manufacturing industry, let's say some CNC machine, or how blockchain can be used in
Yes.
that kind of assets.
So for example, suppose in a supply chain management, we have our goods that is traveling from one place to another, isn't it? So that good is our asset, and we can use blockchain to secure that supply chain management. We can use that to trace our good, where this thing is heading, what is the exact condition at the moment. So in a supply chain management, actually the concept of this asset is very much used in this supply chain management scenario. So if you explore the role of blockchain in supply chain management, you will be getting this answer for the assets.
Okay, okay. Thank you. Thank you.
Also in healthcare scenario, also our electronic health record, that is also our asset. So in every scenario, we have some asset that needs to be, secured.
All right. Thank you so much, sir. Now, I would like to request, thank you so much, sir, for enlightening us from such a valuable, the knowledge that you have shared with us. And thank you for all the answer that has been answered by you, sir. Thank you so much, sir. Now I request the participant that the feedback link has been shared in the chat window. After each session, it will be shared. So it has already been shared. Please fill the feedback link for the certification.
So thank you to the all the participants and the organizers, and I wish you all very best. And hopefully, it will be a very good learning experience. I had personally checked the different aspects that is going to be covered in this FDP, and Professor Dr. Sudhir Kumar Sharma has left no field untouched. So hopefully, you will have a very good learning experience in this FDP. Thank you, everyone, and have a great day. Thank you, sir. Thank you,
Yeah,
ma'am.
thank you, sir, for all the support and guidance. Thank you so much. All right, now let me move forward with our event. We are honored to welcome our next speaker, Professor Dr. Jublan J. from Sanctis College of Engineering, Kerala Technical University, to share with us his knowledge on the blockchain for digital forensics. Currently, Sir is a certified blockchain evangelist with interest in network security and social media analytics. Works as a professor in Department of Computer Science and lead Centigis Blockchain Lab at St. Gitt's College of Engineering, Kottayam, Kerala. He is supervising doctoral scholars. He is also a certified HR trainer from various professional forums. He holds postgraduate degree in technology management, psychology, and cyber law. He is the current president of Pala Management Association, former vice president, United Nations Academic Impact Kerala, and former president of Engineering Forum Pala. Over to you, sir.
Thank you, Tripti ma'am, for the wonderful introduction. I think my screen is visible, right?
Yes, sir, it's visible, sir.
Yeah, thank you, thank you. And really wonderful introduction session by Dr. Bharat sir, and he is really a trendsetter in anything and everything. And he's already set a benchmark so that we have to work much on for the coming up sessions. Anyway, thank you, Bharat sir, thank you, Tripti ma'am, and thank you, the management and team of our college for conducting such a wonderful workshop in the trendy area, which is really disruptive in the current scenario. And I'll surely share my views on applying blockchain in digital forensics, where digital forensics can be considered as a branch of forensics that encompasses the science encompassing the research of and investigation of materials found in digital devices. Often that can be in relation with related with computer crimes or something like that. And if it's a crime, if it's a crime, it can also be connected as a civil crime or a digital crime in the case of forensics. And sorry, civil crime or a criminal crime means that can also be divided into that. Like in the case of criminal situation, you can go for murders or personal harassment or something like that. And in the case of civil crimes, you can go for crimes regarding the encroachment of properties or rights in the rights of the individuals or something like that. So that makes a difference in the scenario. And I request our participants to mute the mic so that we can have a more enjoyable session. Can you please mute the mic who is already using it? Okay. And now we will be coming to the digital forensics, where, as we told, the branch of forensics, which is a traditional science that deals with the uncovering and interpretation of the electronic data, where each data is stored in a systematic process, so that in the case of digital forensics, you can identify, collect, and recover, and also preserve digital evidences found in various digital and electronic devices. Also, coming to that area, this digital forensics means I'll align my session 50% for providing some light on digital forensics, as well as how blockchain can be integrated in the next 50%. Now we will discuss that with the help of a case study also. And in the case of digital forensics, where we can have various branches like data forensics, cloud forensics, mobile forensics, memory, as well as the network forensics. By the name itself, we have a good idea on what these branches deal with, but still we have to check into what each division has and what are the different tools used for identifying and scratching the evidences in the systematic manner. And here, in the case of data forensics, which we can discuss as a technique for reassembling the files from the raw materials or raw data fragments when no file system in the metadata is available. So that data can be collected, and common technique, it also can be connected as a device as a common technique for data recovery after the storage device is failed or destroyed. So the more effective things has to be done in the management of digital data, and data carving can be one of the method that can be used in digital forensics to provide these unavailable or destroyed data. And here the tools used for means this forensic data forensics can be the scalplets, EBT extract, or also bulk extraction tools are also in this mechanism. And you know, for the past few decades or past 1 decade, cloud is providing a huge role in the life and technology where your data can be stored in clouds, and the details that are stored in the cloud is stored in the secondary method, and you have to go for a specific systematic approach to collect the evidences from the data stored in the cloud, as well as you have to go for more intimate and interrogative steps to be taken. And it is considered as one of the subpart of the network forensics, where the crime is done on the cloud has to be interrogated and examined in a tough manner. And there are various limitations available in the examination of cloud forensics. And UFED Cloud Analyzer and Post are some of the tools that are involving in identifying the evidences which is available in the cloud system. And also, mobile forensics is ever-growing area where various crimes using the mobile phones, which are very familiar to us, are happening. And even in the lockdown time, as we are all aware, such crimes using the mobiles have been increased tremendously, and attacks towards people's personal space also has been increased. And here major issue is coming under this area of forensics, that is mobile forensics, and the examiner has to infect the way properly to find the correct information which is available in specific system, even it is damaged or erased or destroyed. And standard tools used for such mobile forensics are NKs, and some of the tools used are NKs and access data imager, where you will be taking, with the help of the FTK imager, you will be taking the image of the system and image of the memory space stored, and you have to properly examine the transactions, memory transactions happened, and the activities happened with the case of the NK. And again, in the case of memory forensics, the examiner is supposed to investigate and analyze the data that is removed from the system. That is, even the people who have done the crime, or the victims might also be, unfortunately, have removed the data unexpectedly from the system. And memory forensics have wonderful tools to recover the data which have been deleted or destroyed. Not more than destroyed, even if you can make that factory reset, etc. in the case of mobile. Still, there are technologies to get the details back, and at the memory level, nothing is encrypted, and here in this level, nothing can be hidden because of the availability of the tools like MFT dumper and the tool with volatile. But still there are some ways to bypass this methods, but systematic approaches will always improve the image of the inquiring people with the help of the proper forensic mechanisms. And such one of the area is the network forensics, where you have wonderful tools available like Wireshark, which you are already familiar with. Then the network miner or TCP dump or something like that, where all the data is collected in the systematic manner, and even the manipulation which has already done can be identified and properly checked out. To work with the basic challenges of digital forensics will surely provide you an insight on how and why blockchain has to be incorporated in this system. Bharat sir has always provided you a clear picture on how this means what this blockchain is, and where this system can be implemented and how that can be implemented. And I present you before the help of this use case, where how this using blockchain effectively digital forensic issues can be prevented, issues or problems in managing the digital forensic evidences has to be taken care. And here the issues and challenges include basically in three categories. One is the source related issues and challenges. Second is the law related issues and challenges. And the third is the science related issues and challenges. And in the case of related, in the first case where we are discussing about the source, that can be directly on where this problem has occurred or how this issue has happened. All these things come under these challenges, and this has to be means when the number of crimes increases, you have to even store enough data in the systematic method, or store the images in the systematic method, so that properly that system of storage has to be scalable. And also the collection and visualization of digital evidences has to be systematically done, so that you are producing it before the law or court, or you are producing it for analysis, etc. Very systematic procedure has to be followed to ensure that you have to manage that evidences without tampering and getting destroyed. And if coming to that point, how this can be tampered? Means if I'm a person who collected the evidence with the help of tools available in a systematic way, and I am storing that in the computer system means I'm a person who is obeyed to law, means from a specific police department or something like that, and I'm storing that in a specific system very safely. And even the system has access by the senior officers or many of my colleagues. So when they enter into the system, if some changes are made by the people with their privileges available to them, when presented before the law, then automatically the forensic details which I have collected, the evidences I have collected, will be changed and is directly affecting the interrogation. And also, you are means provided for, if I'm keeping it safe and you are going to present it before the law, that is in the case of court, then you have to go for another challenges and issues you are going to face. Basically, most of the digital evidences are only taken as supporting evidences before the court, and they are not taken as some of them are not considered as the primarily evidences. They are only considered as supporting evidences, where you means because of the primitive systems followed by the law and order. Technology has grown a lot, but not all these changes that has been grown are adapted by the law or the courts in various parts of the world. Because of that reason, means there are very critical things that such tamperings which I have discussed can be even happening at the court when you have already presented before the court. And also, so there has to be serious steps to be taken for the presentation and prevention of the evidences in the court. And also, the validity of the evidence, the, the credibility of the evidence has to be properly presented before the court. For all these things, if the court is, even after all these steps have been taken, if the court is not taking this as a primary evidence, then it can only be provided as a supporting evidence to the primary evidences which have been already provided. So there are some issues. So these are another issues, but this is not coming under the scope of implementation of blockchain. But still, the tampering that which I have already discussed will come under directly under the implementation of blockchain in forensics. And another one is the scientific related issues, where there are very improved anti-forensics techniques which are available. Anti-forensics techniques means those techniques of technology which has been evident to destroy the forensic evidences which have been collected by the cops. So advanced anti-forensics techniques are available. So any changes or any problems, evidences which have been already taken or already implemented has to be, or already acquired, has to be kept in a safe custody. And at this point, we have to have also enough system, enough good and equipped hardware components to store such evidences. And again, usage of anti-forensics techniques and its prevention comes under the scope of blockchain, but the hardware components which are unavailable cannot be implemented, taken care by the system. So even like this, even at this stage, many of the challenges in the source-related issues, law-related issues, and scientific-related issues can be overcome by implementing the blockchain in digital forensics. And before coming to the implementation of the system, we can just check how this legal framework works in the case of digital forensics. Here, there are 6 basic step-by-step mechanisms where all these mechanisms are documented and managed in a very systematic manner. Here, first step in that is the identification or the preparation. In the identification and the preparation phase, you are going to identify what the incident is, what incident has already happened, and identify the problem that has already happened. And you are going for equipment or techniques and technology, and again tools which can collect the evidences of that specific incident, and checking for how you can authorize that mechanism in the systematic way. All these things are coming under the first step of identification and preparation. And next step is another critical step where you are going for search and serialize, where you are going to recognize what are the evidences and means collect that evidence in the systematic way with the help of the tools and technologies you have already gone for during the first step. And in the next step, that is the preservation of the evidence obtained, you have to make that mechanism secure, and surely the integrity and the credibility of that specific evidence has to be taken care or protected so that no manipulations will happen in that specific stage. So all these identification, searching, and preservation, along with the other three phases, all these small changes which are happening will be documented in the legal framework, that is systematically documented in the legal framework. And here, and the next case is the examination, where you are going to examine the duplicated evidences which are already available. That is, you are going for duplicating that evidence and storing to that to the safe custody, and also recover the data which is already available. Duplicating the evidence comes to a process of imaging, where that specific evidence has to be moved to another device where all the actions will be happening, or all the efforts for taking out evidences and all the efforts for working on it will be happening on this image. And the next stage, you are going to analyze what issues have been happening, what issues have been taken care in the case of determining the process. And here you have to identify or determine what are the problems occurred, and you have to analyze the significance of that specific case, and you have to come into some conclusions.
What you are doing till now? Yes.
Excuse me?
In both the programs.
Some conclusions into that, and the final stage is to report, or you have to conclude in a systematic mechanism and submit it to the process which you are planning to. And in this, you are having a life cycle of managing the evidence, where you are collecting the evidence, examining it, analyzing it, and then reporting it and presenting before the court, and finally settlement before the court. This is the life cycle. And as you know, after the collection and the evidences which you have gone, then analysis is done properly, and made changes in that, and then we are going for the next phase. And the same is the case of in the next of examination. If you are having no proper conclusion of the examination, analysis part is done again, and it is reworked. And this in this pattern means you have all those things in the previous framework, and this process will happen till the reporting, and after the reporting it is presented before the court. And in the case of digital forensics, you are dividing that into three basic zones, that is inside the computer, just connectivity points, and outside the system. That is, you can be considered take that is internal network, the middleware area, as well as the external network. In the case of zone 1, that is the internal network, that is purely related to all the things that are happening inside the system as well as happening inside the network. And in the case of an institution of organization, all other things except just after the firewall will be coming under the middle area. That is, it comes to the gateways, then it comes to the boundary services, it comes to the authentication mechanism. All those things will be in the middleware area, and the packet tracing, applying logs and firewalls, etc., all happens in the zone 2, wherein you are acting as a you are identifying that this is an area where an interface between the external network and the specific network is happening. And third is the external network, that is including the cloud services or the web services or the database servers, which are purely residing external to the network, but you are continuously connecting and working and integrating the this type of equipment. So basically there are the various zones which we are going for functioning, and then the digital forensics has an important term called the chain of custody, where it can be defined as a process used to maintain the document in the chronological history of handling the digital evidence. That is, if you have a digital evidence with you, you have a tracking record on that. You have certain transactions happening on that. You have some of the changes, or you have some of the manipulations or something like that happening on that specific evidence, and its timeline can be defined as a chain of custody, where it passes through various levels of hierarchy in the system, and it's very hard. I mean, in the case of digital evidence, it's very hard to preserve and identify, even if such things happen. So, in this chain of custody, which we just discussed in the case of identifying a digital evidence, as you know, working on a paper, that is identifying that timeline on a paper, is a very tedious step, more than tedious. It is not practical, just because all the small changes or transactions or events happening on a specific data, it's you find tough to make it or mark it in a paper. But you can identify that each transactions can be checked and stored in a in a digital format, which is more practical and more expected. So, if such digital formats are kept in certain areas, you should ensure that it is not tampered, it is not manipulated. For that, means storing that digital data in a storage, mainly means best the worst challenge which is faced in this area is that it can be easily tampered by another person. So here, the strong and automated system is required to manage these things, and for that we are trying for the digital evidences, or so that we are studying for checking for the implementation of blockchain in cyber forensics or digital forensics. And basic challenges, as we have already discussed, are presented before you. And now coming to the systematic implementation of how blockchain can be implemented in the process. That is, previously when we discussed about the legal format which we studied, there every event was connected and documented, and now we make a small change that this documentation process will be linked to a blockchain. That is, you are trying for a blockchain-driven process model where all the 6 phases which we already discussed will be integrated or linked to that. So any changes which is happening in identification phase to reporting phase will be, previously it was documented in a documentation mechanism, which is now changed that documentation is directly going to get integrated or directly going to get stored into a blockchain, where you cannot tamper, you cannot change, you cannot remove any of the steps which you have already committed. And that is the power and beauty of blockchain, where any data which is already connected, means already linked to a block, has can only means it is practically impossible to make that changes effectively, or tampering done effectively. Practically, it is impossible for many reasons. And even if, as I told in the previous case, one of my colleague is trying to make some changes, that transaction time, including the time when you have done, as well as the privilege of the person who has done that, will be recorded in this. And if he is a person who cannot, if he is a person who is not privileged to make that changes, blockchain itself will prevent him from making the changes. That makes the system very wonderful, and in today that makes ensure that each digital evidence will be systematically stored, and if any tampering or change of evidence happens in between, it shows that will show a clear light on who has done it and how he has done it, because all the nodes associated will be directly connected to the blockchain, and they will be passing messages one to one, where this identification can easily be done. And now we have to go for a feasibility test on whether this has to be done in the chain of custody. That is, if really blockchain has to be integrated to a chain of custody. Means integrated to the forensic chain of custody. This can be even applicable for many other cases where the blockchain, to check whether the blockchain is really required or not. So we can go for that specific testing flowchart, and it has a chain of custody here. And the question arises here is that, is there any requirement of storing that specific state? Any state has to be, is there any requirement of storing that specific data to that specific node? Means all that if it is requiring that chain, then then you have to go for some storage mechanism. And if it is not, you don't have to even store it, and for that case you don't need a blockchain at all. And if you are storing that specific state, that is if it means even my mark means I've evaluated my students' mark, and I'm updating that on the Excel sheet, and many people will be having the privilege to do that. Means see that, including the class teacher, HOD, or other teachers who are included in that. All will be knowing what the mark is, because I have already shared that specific sheet. And so if any change is happening, means any changes happen done on that mark by any other person, you have to directly check on who has done it. So here, next requirement of that implementation blockchain is that, do we have multiple writers in that specific system? If I am only the person who is going to write on that, if I am the only person who is privileged to write on that, then there is no need of blockchain, because I can believe on myself, right? Yes, I can believe on myself. Anyway, without my knowledge and without my confidence, I cannot make any changes myself. So for that reason, if it is happening, that is more people are there, again there's a chance of using the blockchain. Yes, if I am the only person using the that specific writing on that specific node, then there is no requirement of the blockchain. And third case is, can we afford to have a trusted third party online always? What is a trusted third party? Again, if you are transferring money from Delhi to New York, surely you are not sending that on an aeroplane, but you are going to deposit in a bank, which you have an account, and then you are asking the person to asking the bank, might be State Bank of India, it means in the Vasant Kunj or something like that, your account, Vasant Kunj branch or something like that, you're having the account, and then you are then transferring that money to New York. And again, you are transferring that to the Madison Square branch, Madison Square person who resided in the Madison, near the Madison Square. And you are transferring that to Citibank of New York, where it is available. And here, two people are they have trust in each other, but they have to have intermediaries like State Bank of India and Citibank, where this money is transferred in between. They can be told as the trusted third party, and only the problem over here is that when we transfer that money, some money is deducted from our account as the transaction fees. So you should have a trusted third party, means that will always be a costly effort. So, but if you have a mechanism to have a trusted third party, then again you don't need a blockchain. But you have multiple writers over there, okay? You have to store that specific state, and you don't have a third party, then you have to go for implementing a blockchain to writing that into a blockchain where it will be systematically recorded time to time. And so we are identifying at this case you are using a blockchain. And now we are going for what type of blockchain you are going to use. The blockchain I am going to use is basically based on my requirement. That is, if all the writers in the system are known to each other, that is, all the people who are involving in that mechanism are known to each other, then that is, you are storing that data and the network is purely in a police domain, police state of police of a specific state. Okay, if it is so, then you are going to means you know that all the people each other, and you know these are the people. So you can go for a permissionless blockchain, just because you know all the people in and around, and only you have to know is this thing, who has made the change and what change has been made. So that transaction or that specific state will be stored, and that indicates who has done that specific change. But since it is inside a specific organization, or all the writers are known to each other, you are going for a permissionless blockchain. Okay, you can use that for permissionless blockchain. And if it is, if you are knowing, means if all the writers in the trust systems are trusted, that is, you have to trust all the writers. Okay, if it is so, all the people in the people are trusted to each other, then again you don't have to have a blockchain. Just because I trust all the people in and around me, and I'm sure that nobody is going to make any changes in that. But if I am not trusting the people, even inside the organization, then I have to go for some other choice. That is, if I am going to go for that, I will be going for a public permission blockchain. Okay. If they are requirement is for public verification, means you are going for means you can go provide that for the public people, you can go for it. But if not, you have to check for a private permission blockchain. That is, I have to check for a private blockchain for the usage of my organization. So this is the pattern where you identify the impact of usage of blockchain in the system. And now we are trying to come across with a specific case study where a forensic chain of custody can be done. That is, in a small project which we came across, or we did, we are just trying to identify you how the system works. And as we have gone through the blockchain system and scenario, using the implementation of blockchain surely guarantees the transparency, security, auditability, and authenticity of the system. And also, every transaction made on the evidences get recorded systematically and identify who has made the transaction. These are the benefits of implementing blockchain in the specific chain of custody. And in the case of forensic chain of custody architecture, I, along with my team, has gone for 5 basic components. That is the participants, the front end, the core module, blockchain network, and distributed evidence. And here, evidence store. And here, basically coming is the 5 category. The operation flow of blockchain is here. You can check into that. And this is coming as the participants group. And the participants will be the creator of that specific evidence, or a person or a team who is owning that evidence, or other participants like legal people who are connected to the network, etc. Okay, that is the basic set of participants who are involving in the chain of custody management using the blockchain. And there will be another component called the front end, where you will be trying to manage all those things to happen. You will be trying to manage all those things to happen. You will be just this front end will be in responsibility of getting integration with the other components of that specific system. And now there is a core module where all the transactions happening are managed with the help of specific algorithms which have been predefined. So at this case, you are responsible for or the core module is responsible for any decisions or actions taken in the forensic chain system. Without the permission of this core module, no changes can occur in the specific system. And coming to the next level, it is the basic blockchain network, where decisions of this core module will be stored in the specific blocks. That is, all the transactions and instructions produced in this specific flow, or specific stuff happening in the specific system, will be systematically stored in the system, in the network, with the help of a blockchain network. And here, smart contracts, which we have already discussed, will be playing a pivotal factor to identify what type of storage it has to be done and how it has to be stored. And again, the final area is the distributed evidence store, where you are going to store all these transactions, and you cannot make any changes without a credibility. But you can make changes, but you have to make changes with a proper credibility, as well as you have to get the permission that you are doing in a systematic way. As I told, the 5 categories are explained in this slide, and it indicates all the factors which I have just explained. And the components basically involves the evidence ID, where it uniquely identifies what the evidence is, and it is encrypted with SHA-256 algorithm and encryption mechanism. And owner can be described as a participant and who is possessing that evidence, or to whom that specific evidence is available, is identified as the owner. And along with the owner, you have another person called the creator. And the creator is the person who make that specific digital evidence, or that who enters that specific evidence. And case ID is the unique number to assign to a specific case. Yes, as there should be some key values. Here, case ID is used as key value where you are identifying a case with the help of this identification. And regarding the transfer time is the time of transferring data and all the time means timeline on what transaction has done or from that array that will be perfectly noted in that specific system. And transfer chain can be described as the array containing the address of the participants in possession of the evidence. That is, who all has the credibility or who all has the privilege to possess that specific evidence. That is in the transfer chain, and evidence description will involve all the essential attributes related to the evidence. That is, additional attributes which are available that will be stored in the evidence. Now we will be having means basically what are the components of evidences. That is, we have just discussed about the owner, creator, etc., and all those values. This will be having a specific thing, and in the case of functioning of that chain of custody mechanism with the help of a digital evidence that works in that is explained in this specific system where all these nodes of the forensic chain, all these data of the forensic chain will be stored in this specific transaction list, and all the participants who are involved will be connected with the help of an intermediate mechanism where it has a forensic chain with Angular applications, and also APIs are there, including the business network archives, which are three components which functions together. And basic algorithms over here are checked for the evidence creation, evidence transfer, evidence deletion, and evidence display. That is here. What is evidence creation? That is just from the name indicates you have to create a new evidence. So if the evidence is already available, you are not going to go that. But in the case you are going to create a new evidence, you have to go for some specific steps. And again, and you have to transfer that evidence from one specific node to another. That is, you have to move that evidence to some appropriate addresses in the specific chain. You have to for that also there is a specific algorithm where you are going to transfer that, and the ownership will also be transferred during this phase. And also after that transfer is happening, you are pushing that into that transfer chain of array and transfer time array to identify when and how, who has, to whom that has transferred and when it has been transferred. And finally, if you have to delete some evidences, that evidences has to be means that deletion process has to be done by the creator or the owner, and then the creator will be responsible for removing that from the chain, because he is already having the privilege to manage that data or proof of the blockchain. And coming to the last step, that is the evidence display, where you have to show that evidences in the forensic chain. Then you have to check for where that is stored. You have to go for that specific address, and you have to display that where you can produce that evidence before the higher authorities or before the court. So these are the basic systematic approaches happening over here. And now going to the means implementation in a stingy manner. You have to go for in this blockchain system. You have to go for collection of evidences and storing it in one place, and then these stored evidences has to be stored in the repository available, and that repository is integrated or that repository, that values are encrypted with the help of using encryption technologies by hash function, and also it is added digital digest to that, and in the next process reports are taken after the proper analysis, and all these things, all these processes happen in this evidence management area of the system, and since it is encrypted and transferred, this will be directly stored into the various blockchain ledgers, uh, which is in the acting as the middleware of the system. That is, each and every transaction, or each and every event, or each and every stage of a specific evidence will be integrated with in the means will be marked in the timeline, and that will be stored in various blocks of blockchain ledgers. So when time progresses, you are not going to save all the data into a single block of the blockchain, but those data will reside based on the transaction. Those data will be reside on apt areas of the blockchain, where when and where it is required, it can be retrieved easily from the blockchain with the help of a specific algorithm. And then this blockchain is directly connected to the court, prosecution, and defense people, where all the processes can be taken from there, and involvements taken care from there and functioning about it. And I think we have a few minutes for questions, because I'm going for another level of IoT forensics, where if you are interested, else if the time permits, we can go for some other questions.
Yes, sir. Thank you so much. Let's take the question, sir. Participants, any questions from your end? Participants, any questions from your end? All right, sir.
No, ma'am. It's very nicely explained by Dr. Jubilant that all about the blockchain. It is very, informative session. Thank you so much, Dr. Jubilant. Thank you so much.
Thank you.
Thank you so much, Raj, sir. All right.
Dr. Jubilant?
Yes, please.
So very morning. I'm Deputy IG Venkatesh. I'm calling from, I'm an MOD officer. I just wanted to know whether can we use the sense of this forensic, digital forensic, which you are telling about the blockchain. Can it be used in terms of the maritime industry as well?
I think we can easily use the blockchain in the maritime industry for many complicated issues. For example, sailing during the sailing at different seashores, you are having different rules, right, sir?
Correct, sir.
Yeah, and again, you have some intermediate people who are ensuring that all the licenses to come to that specific shore is okay before you are reaching the shore. Am I right, sir?
True, I agree with you.
Yeah, and here, if all these different governments, maritime rules are connected using smart contract to the blockchain, I'm sure that these headaches of and all these rules keeps on changing, including the environment related rules, including the climatic or economic related rules. It keeps on changing, and because of this reason, if these rules are updated on a smart contract in blockchain, you will find it very realistic to identify that you can compare the specifications of your specific ship, and you can easily identify which all the rules are compatible and which all rules are not supporting your existing system. And that saves a lot of money, that saves a lot of time in the maritime industry, I think so. Similarly,
thank you very much, sir. Thank you very much. Because when you were mentioning about the smart concept, then I thought because the future is smart code concept, so I was thinking why not write a research paper on this and then try to borrow some ideas from you and then take it forward. Thank you very much, sir.
Thank you, sir. Thank you, sir. I'm really interested for that.
Thank you, Dr. Tripti, madam. Thank you very much for giving me this opportunity.
Thank you so much, sir. Any more? Thank you, sir. Any more questions? All right. Thank you so much, sir, for your precious time and efforts you took to share your vast and valuable knowledge with us. I once again would like to express my sincere thanks on behalf of IITM to all the speakers for their eminent presence to the session. We thank you for being with us this time. It has been a great pleasure listening to you all, sir. As we have reached towards the end of the day one of our one-week faculty development program, I would like to thank all the research scholars, faculties, industry professionals for joining us in this informative session. You all are welcome to join the session tomorrow at 10:30 a.m. And the feedback link has been shared in the chat window. Kindly fill the feedback form, everyone. So can we have one selfie, please? Everyone, kindly switch on your camera. I request all the participants and a speaker to switch on the camera for the selfie photograph. May I request everyone to switch on the camera, please? Oh, yeah. Yeah. All right. Yeah, it has been done. Thank you so much. Thank you, Venkatesh, sir. You're there in the office, I can see, and you have attended our session. Thanks a lot.
Thank you. Tripti, ma'am, it was a great opportunity. Thank you, ma'am.
Same here, sir.
Venkatesh, sir, thank you.
Hello. Hapati, ma'am.
Yes, ma'am.
It is Bharti Priya from BVLIT, Hyderabad.
Yes, ma'am.
Ma'am, I couldn't find the chat window to get the feedback link.
You are connected with MS Team, ma'am. Is there the chat window? You can see the chat window where the participants are there.
Yeah, it is there, ma'am. The participants are there.
Yeah, then next to that, there is a, ma'am, a chat emojis will be there. You can just click there, ma'am. You can see that chat pic is there.
No.
Actually, Tripti, ma'am, it has been deactivated for the outsiders. Outsiders, we are not have access to, the chat window. So it is only for maybe the IITM fans.
No, it's not. It's disabled, ma'am.
It is available.
It is given on WhatsApp group.
I think it is disabled, ma'am. Go to setting.
All right, those participants who are not able to see in the chat window, we have a WhatsApp group also. You must be knowing that. We have put the feedback link out there also. So you can take from there also, ma'am. You can fill the form. All right. We have shared. Yes, ma'am.
I'm not in group.
You are not there in that group also. All right. You have my number?
Kindly,
Yes, sir.
Madam, can you kindly send me through mail, email ID?
Yes, sir. Ma'am, please kindly send this through email ID.
All right. You have registered. You have registered yourself, right? Ma'am, check once. If can you see now the feedback link? Can you see now? Sometimes it happens that you face a problem through this. You cannot directly open it. Then through mail you can open it. Sometimes it happens.
Okay, madam.
Yeah, Ravinder sir, it's fine now. You got the link, Ravinder sir?
I got the link.
All
I've done that.
All right. Thank you so much.
Thank you.
All right. Thank you so much, sir. All right. Now, see you all tomorrow at 10:30.
Yeah, ma'am.
Yeah, ma'am. I'm not able to get that particular link.
Ma'am, do you have my number?
No, ma'am. I don't have.
All right, ma'am. Share your email address, please.
Yeah, it is CHNDA.
Can you type in the chat window?
Ma'am, actually, chat window is not visible to us.
Not visible. Okay. Yeah, please.
Yeah.
Yeah.
CHA.
Yeah.
N.
Yeah.
DA dot.
V for victory, right?
No. It is CHA Chanda. CHANDA.
All right.
Dot. Chauhan. CHO.
Oh yeah.
UHAN.
Right.
@gmail.com.
Sure, ma'am. We'll send you there.
Okay. Thank you. Thank you so much, ma'am.
Most welcome.
Ma'am, this RT again. Even for me also same. Even I couldn't able to get here.
Okay, no
Can
problem.
I tell my mail ID?
Yeah, sure, please.
RTAA.
Yeah.
RTHI.
After RTHI, all right.
No. RTAA RTHI. Priya. PRIYA.
After RT, what you said, ma'am?
Priya.
Yeah, fine.
Yeah, PRIYA. Priya. Dot R.
Okay.
Dot R.
Yeah.
@ BPRIT. B for victory.
Yeah.
R for Roy. I for intelligent. T for toy. BVRIT. .ac.in.
Okay, ma'am.
Madam,
even along with actually many of the people.
Ma'am, what you do is you give me your WhatsApp number. I will add you in that WhatsApp group. You give me your WhatsApp number so that
Okay. Sure. 9944
9944
177
177
307.
307. Yeah, ma'am. I will add you in the WhatsApp group too. Fine, ma'am.
Yeah, sure.
Madam,
yeah, thank you so much.
Madam, can you take my number, madam? WhatsApp.
Sure, sir. Please.
90.
Hello.
90
35
35
64
64
16
16
32.
32. What's your good name, sir?
My name is Dr. Patel Nagaraj Gaud.
Dr. Patel. All right, sir. Yeah, I will add you in the
Madam, can I
WhatsApp
give me mail ID?
No, sir, it's enough. I will going to put in the WhatsApp group. All the information will be shared there. So we can chat
Thank you
out
so
there.
much.
Yeah, well.
Hello, ma'am. Good afternoon. Good afternoon.
Good afternoon, sir.
Also.
My name is Vaibhav Sharma and I am from SGR Dehradun.
Yes, sir.
Ma'am, I find the same problem. There is no chat window enabled for my phone.
All right. Sir, are you there in the WhatsApp group or not?
No, ma'am.
All right. Please give me your number so that I can add you.
8279
8279
70
70
84
yeah 84
91
9
1.
All right. ठीक है वैभव sir, I will add you.
Okay, thank you.
Welcome.